This is one of those battery-powered power stations that I did a sponsored video on last year, and the output from it is a very nice looking sine wave, much better than we get from the power company, but not always. And before the saw is turned on, the waveform is nice and clean, and then it gets really messy, and the duration of that is 370 milliseconds. And if we zoom in on this mess, we see there's some very high frequency oscillations on top of the regular sine wave. And putting the cursor on one period of these oscillations, it says it's 7.8 kilohertz. But I wasn't aware of this problem when I did the sponsored video with this battery box. In fact, I was pretty happy with how it worked, and they were pretty happy with the video. Only afterwards I realized my kilowatt meter was no longer working. So I decided to investigate that. And using images from my time-lapse camera that I usually have running while I'm filming, I was able to establish that the exact moment that this thing stopped working was when it was plugged into this power station and the circular saw was plugged into it, and I was doing some cutting with it. So I decided to investigate what's coming out of that battery power station using my analog scope. And I was using this old analog scope because my USB scope couldn't handle the voltages, and I didn't have this one yet. And sure enough, I was seeing some strange waveforms when that circular saw was starting up, but I wasn't sure, was it because of the power station or was it the circular saw that was causing it? And I figured the easiest way to switch back would be to just plug the power station into mains power, at which point it just feeds through mains power, and test it again to see if I was still getting those waveforms. But then all the lights turned out. But this scope connects its ground to mains ground, and I had the scope's ground hooked up to neutral on the power station. And on this box, neutral isn't ground. Both of these are actually kind of equally hot. And it's supposed to survive tying neutral to ground. In fact, the company even tested this themselves after I reported this and showed that it wasn't failing. But I know that as soon as I plugged that thing in and plugged that into mains, I had neutral tied to ground and it stopped working. It was dead. And the reason the lights went out in my shot when it failed is because it put a dead short on the mains input and popped the breaker. Thank goodness for breakers. But even though I blew up their battery box, the relationship wasn't screwed up yet. In fact, I managed to convince them to send me a new inverter board to swap into it to fix it. And this is the inverter board. This is actually the old one, and it basically goes in the top of the box right about here. And after that, I used a bunch of resistors to drop the voltage down enough so that my USB scope could handle it, captured some waveforms, and sent them to them. In the meantime, they sent me these two boxes, which is basically a newer, bigger, and better version of the other box. And using this box here, you can tie two of them together in sync so you can get 240 volts. And I can run my table saw off of that. I'll just plug it in and turn it on. And there it goes. Once it's up to speed, it doesn't actually consume too much power, so 200 watts off of each one of those. This circular saw uses actually a crazy amount of current when it starts up, which probably is what triggered this problem. And since these boxes are bigger and better and newer, and they already knew about this problem, I figured no problem, they'll have this fixed on these ones. But just to be safe, I tested again. Got my scope hooked up to this box, which I'm leaving on the floor because it's very heavy. It's got wheels and a handle for moving it around. So the duration of the problem here is just 39 milliseconds, so much less than with the other one, but we're still seeing this problem overall. Very similar sorts of oscillations here. And looking at one period of this oscillation, it says here 5.5 kilohertz, so a bit slower, but as you can see, the frequency varies. So I pointed out to them that the newer boxes still have that same problem, and eventually the response was, well, under those circumstances, this is normal behavior. Well, I wasn't willing to accept that as normal, so this is the email that I sent to them. And what's significant about this email is they didn't reply to this one, and they have not replied to any emails from me ever since. And that was 8 months ago, so I guess that relationship is screwed up. And the contract I had signed with them initially was for a much shorter duration, so I'm definitely off contract with them. I guess we'd reached an impasse about a defect that I felt ought to be fixed and they didn't want to fix. And really, from their perspective, it's like, who is this random YouTuber telling us to change our product? He's supposed to promote our product. That's what he's paid for, right? Whereas I'm saying, this needs to be fixed. I don't want to be standing behind this if the product has this problem. But how bad is this problem? Well, it's actually not as bad as I'm making it look out to be. The only way I've been triggered this problem is by starting up a circular saw, which when it starts likes to draw something like 50 amperes. And it's an inductive load, and it's way overloading the box, and that just puts it into a circumstance that the designers hadn't thought about, and so it goes into unstable oscillations. But most power tools, at least power tools without any electronics in them, which my circular saw doesn't have, aren't going to have any problems with this sort of waveform. So is it really a problem? Of course, you may have sensitive electronics, but sensitive electronics will never put that sort of current surge on it. So sensitive electronics will not see this kind of spike in current, and power tools with just brush motors in them aren't going to be sensitive to it. So maybe it's not a problem. The only reason I even noticed is because I had my kilowatt plugged in at the same time and it got burnt out from that. So it's only an issue if you're using power tools and sensitive electronics with the thing at the same time. And I proposed to them that I would warn people, don't use this thing with power tools and sensitive electronics at the same time, but they never responded to that part either. But I think for most people using a box like this, they would never hit a circumstance where this would become a problem. But with these boxes, they have another thing where you can hook this up to your breaker panel and it'll back up your whole house. And then it might be more of an issue. Because at that point, you'll have all the gadgets in your house still connected to this thing, and now you use a circular saw. And who knows, some devices might get blown by that. And the reason some low-power gadgets are particularly sensitive to oscillations like this is they use a very simple power supply design, something like this. So they take 120 volt AC and they just put a capacitor in series with it, which means you get a current that's proportional to the rate of change here, run that through a rectifier, and then a capacitor to smooth that out, and a Zener diode to clamp the voltage at the right voltage. And that way you get 5 volts out, very low power, without the need for a transformer or a switching converter or anything like that. So it's a very elegant design. Now, if that inverter also has a 60 volt component at, say, 7 kilohertz instead of just 120 volts at 60 hertz, that capacitor will pass that 7 kilohertz more than 100 times better. So even at just 60 volts, we get 50 times more current here than we expected, and that's a problem. And my kilowatt uses this sort of design for the power supply. So there's this little power metering gadget, or this thing here, which was some kind of ultrasonic pest repellent device. There's 2 of the diodes of the bridge rectifier here. Here's the other 2. Here's the big condenser. And this part here, the big yellow thing, is the condenser. But they were a good company to work with. I was working directly with them, not through some sort of agency. And it's way better than doing something like NordVPN. I tried doing a spot for that, but I just couldn't because it required saying things that aren't really true, and I can't do that. And because I don't like working through agencies and I like working with physical products, it turns out all the sponsored stuff I've done was with Chinese companies, because North American companies, it's all about VPNs and peddling mattresses and mobile games or razors. Just can't do it. And I'd been meaning to make this video for some time, but I've been humming and hawing about it. But recently I've just been approached by another company that makes one of those battery power stations, and I figure before I go ahead with that, I should make this video and send them a link to it so that they know what I'm about. And if they still want to deal with me at that point, then perhaps we'll go ahead with it. We'll see. Well, here's an embarrassing thing to admit. I published an earlier version of this video this morning, and there's lots of comments about how this is such a problem, da 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 da, really worse than I intended. But then I thought, well, let's see if I can mitigate the problem a little bit, and I decided to do some more experiments. And then I noticed I had been using a switched power cord to feed the signal into my scope, and this little switch here was off. And how could I have not noticed this? Look at the signal, switch it off, gone. But I started by just pushing the auto button on the scope to get the signal, and there's my signal. It's still there even though the switch is off, because it capacitively couples enough to get the signal, but it's at an entirely different scale. and that I hadn't noticed. And the problem with getting the signal capacitively coupled is it emphasizes high frequency components quite a lot, and that made the high frequency oscillations look about 4 times worse than they actually are. So it's one thing to talk about a flaw in a product, but to make that flaw look 4 times worse because of a mistake of my own, well, I couldn't leave it like that. So I took the video down as soon as I knew that I'd made that mistake, and then I reshot all the parts showing the scope screen and showing the waveforms. But also some of the comments were interesting because some people are saying that this sort of instability at startup of a universal motor hooked up to an inverter is actually not that unusual. So the company saying this is normal may actually not be that far out of line. It's still a problem, it still blew my kilowatt meter, it can still cause problems with other electronic devices, but it's not unlikely that other battery boxes like that will have a similar problem.